Hello students, today I am going to discuss problems on Besses formula. Okay, so coming to the first problem, if f of 20 is equal to 14, comma f of 24 is equal to 34, comma f of 28 is equal to 35, comma f of 32 is equal to 40, then find f of 25 using Besses formula. Okay, so here the x values are 20, 24, 28 and 32, and the corresponding y values are 14, 34, 35 and 40. Okay, we have to find the value of f of 25 by using Bessel's formula. So once again, here also we have to choose x naught. Since we have to find the 25, f of 25, and the 25 lies in between 24 and 28, so we can choose any of the value as x naught. So, but here I am choosing x naught by 24. Okay. So coming to the solution. So first we have to find u naught, u. So u is equal to x minus x naught by h. So this is the formula. We have to find the value of u. So in this formula, the value of x is nothing but 25. Okay. So the value what we have to find, that particular value should be treated as x minus. So x naught, I am treating x naught by 24. Okay, I am taking the x naught by 24. By h, the interval of difference is 4. So the difference between the x values is 4. So that we get 1 by 4, which is equal to 0.25. So this is the value of u. After that, we have to construct the central difference table. So once again, we have to construct the central difference table. Okay. So coming to the table, the first column is values of x. So here we have to write the values of x. After that, we have to write the values of y or f of x. Okay. So coming to the x values, we are having 20, 24, 28 and 32. So these are the x values. Coming to the y values, we are having 14, 34, 35 and 40. So these are the corresponding y values. So now coming to the differences. So the first differences, so delta f of x. So 34 minus 14, so gives 20. 35 minus 34 gives 1. 40 minus 35 gives 5. These are the first differences. So coming to the second differences, so 1 minus 20 gives minus 19. 5 minus 1, 4. 5 minus 1 gives 4. So coming to the third differences, 4 minus of minus 4 plus 19, which is equal to 23. Okay. So coming to the names in the table, since we have chosen 24 as x naught, so the values below x naught can be named as x1 and x2, and the values above x naught can be treated as x suffix minus 1. And the corresponding y are, so this is y suffix minus 1, so this is y naught, so this is y1 and this is y2. And coming to the names of first differences, so the first value is, so this is delta f of minus 1 and this is delta f of 0, and coming to the next one, that is delta f of 1. Since the first value in y is y suffix minus 1, so the first value in the first difference is delta f of minus 1. Similarly, coming to the second differences, so the name of the first value in the second differences is delta square f of minus 1, and coming to the second one, this is delta square f of 0. And finally, So in the third differences, the first value is delta cube f of minus 1. So in this way, we have to give the names for the values in the table. Okay. After that, we have to write the formula, that is Bessel's formula. So we have the Bessel's formula is okay. So once again, you have to write the formula. So f of u is equal to 1 by 2 into f of 0 plus f of 1 less the second term is u minus 1 by 2 into delta f of 0 plus u into u minus 1 by 2 factorial into delta square f of minus 1 plus delta square f of 0 by 2. Okay, plus coming to the next term u into u minus 1 into u minus 1 by 2 by 3 factorial into delta cube f of minus 1. So I am writing the formula up to third difference because since in the table we are having up to third difference, so that I am writing up to third difference only. So now we have to substitute the values by seeing the formula. Okay. So once again, you have to round the values in the table. So the first value what we have to round is f of 0 and also f of 1. Here f of 0 is nothing but 34. Y0 or f of 0. We can treat y0 as f of 0 so that we have to round to 34 and also y1, that is 35. So y0 can also be named as f of 0. Y1 can also be named as f of 1. So that first we have to round those two values. After that we require delta f of 0. So the delta f of 0 is 1. After that we require delta square f of minus 1 and delta square f of 0. So the values are minus 19 and 0. Okay. And finally we require delta cube f of minus 1 and the delta cube f of minus 1 is 23. So immediately after rounding the values, we have to draw the arrow marks. Okay. In order to identify the terms easily, we are drawing these arrow marks because in order to identify the terms, what we have to substitute in the formula very easily. Okay. So that we have to draw arrow marks. So from this, we are going to delta cube. So these are the values we have to substitute in the formula. So now we have to substitute. So this is equal to 1 by 2 into, so f of 0 is 34 plus 35 plus, so the value of u is 0.25 minus 1 by 2 is 0.5 into delta f of 0 is 1 plus, once again u is 0.25 into u minus 1 means 0.25 minus 1 means minus 0.75 by 2 factorial is nothing but 2 into, we have to write delta square f of minus 1, that is minus 19 plus delta square f of 0, that is plus 4 by 2. Okay. So next coming to the last term, that is plus u into 0.25 into, once again u minus 1 means minus 0.75 into u minus half, that is 0.25 minus 0.5 by 3 factorial. So 3 factorial is nothing but 6 into delta cube. So the value of delta cube f of minus 1 is 23. So that we have to substitute 23. Okay. So I have substituted all the terms in the formula. So on simplification, we get the value of f of 25 by 34.5928. So this is the approximate value of f of 25 by using Bessel's formula. Okay. So coming to the second problem. In the second problem, we have to find, so y suffix 2.73. It means we have to find the value of y corresponding to the value of x, that is 2.73. Comma, given that we have given y suffix 2.5, y suffix 2.6, 2.7, 2.8, 2.9 and also y suffix 3. values. So by using those values, we have to find y sub x 2.73 by Besses formula. Okay. So once again, coming to the solution, we have to choose x naught first. Okay. So I'm choosing let x naught is equal to. So since 2.73 lies between 2.7 and 2.8, I am choosing 2.7 as x naught. Okay. So you can choose any of the value as x naught, but here I am choosing 2.7 as x naught. So next we have to find the value of u. So u is equal to x minus x naught by h. This is the formula we have to use to find the value of u. So once again, x is nothing but 2.73. So the value what we have to find, so that particular value should be treated as x. That is 2.73 minus 2.7 by the interval of difference of x values. It means whatever the values we are having in suffixes, the difference between those values is not 1, 0.1. So we have to write 0.1. So on simplification, we get 0.03 by 0.1. So this is nothing but 0.3. Okay. So the value of u is 0.3. So after finding the u value, next we have to construct the difference table. So here we get a big difference table, so that we have to construct the difference table. Central difference table. Okay. Right. So the first column is x and the second column is f of x. So coming to the first column, that is, we have to write down the values of x values. So that's 2.5. Coming to the next one, that is 2.6. And coming to the next one, that is 2.7. So next one is 2.8. Next one is 2.9. And the last one is 3.0. So on the corresponding f of x values are 0.4938, 0.4953, 0.4965, and 0.4974, 0.4981, and finally 0.4987. Okay, right. So now we have to find the first differences, that is delta f of x. Okay, 0.4953 minus 0.4938 gives 0.0015. 0.0015. And next 0.4965 minus 0.4953 gives 0.0012. Next, coming to the next difference, 0.4974 minus 0.4965 gives 0.0009. And coming to the next difference, we get 0.0007. And subtracting 0.4981 minus 0.4974 gives 0.0007. So coming to the last one, that is 0.0006. Okay, these are the first differences. So coming to the second differences, it is delta square f of x. So 0.0012 minus 0.0015 gives minus 0.0003. And coming to the next difference, that is minus 0. Once again we get 0003. Okay, so coming to the next one, we get minus 0.0002. And finally we get 0.0001. These are the second differences. So coming to the third differences, delta cube f of x. So the first one is 0. Whenever we subtract minus 0.0003, minus of minus means plus, we get 0.0003. We gets cancelled, so that we get 0. And coming to the next one, we get plus 0.0001. And the next value is also we get 0.0001. Okay, these are the third differences. Coming to the fourth differences, the first one is 0.0001, and the next one is 0. Okay, and coming to the fifth differences, delta power 5 f of x. So we get minus 0.0001. Okay, so these are the values in the difference table. So coming to the values in the table, since we have chosen that 2.7 as x naught, and the values below x naught can be named as x1, x2, and x3, and the values above x naught can be treated as x suffix minus 1 and x suffix minus 2. Okay, so and the corresponding y values should be named as y suffix minus 2, y suffix minus 1, y naught, y1, y2, and y3. And similarly, coming to the names of first differences, the name of the first value in the first difference is delta f of minus 2. Coming to the second one, that is delta f of minus 1. So in this way, we have to remember the names of the values in the table. Okay, so next we have to write the formula of Besses. We have the Besses formula is so once again I am going to write the formula. So f of u is equal to 1 by 2 into 1 by 2 into f of 0 plus f of 1. Okay, next plus u minus 1 by 2 into delta f of 0 plus u into u minus 1 by 2 factorial into delta square f of minus 1 plus delta square f of 0 plus next one is u into u minus 1 into u minus 1 by 2 by 3 factorial into delta cube f of minus 1. And coming to the next term, that is plus u plus 1 into u into u minus 1 into u minus 2 by 4 factorial into delta power 4 f of minus 1 plus delta power 4 f of minus 2 by 2. Okay, here I am writing up to fourth difference only. We need not to write fifth term. Okay, not a problem. Even though we neglected the fifth difference also. So the answer we are getting is an approximate value. Every time we are going to finding the value, that should be an approximate value only, not exact answer. So we need not to write the fifth difference. Okay, I'm writing up to fourth difference only. Okay, so now we have to round the values in the table. Okay, I'm rounding that. We have to round two values. Those are f of 0 and f of 1. Okay, so that is f of 0 and this is f of 1. From here onwards, we have to draw an arrow mark towards this particular value. And that particular value should be named as delta f of 0. Okay, this is delta f of 0. So after that, we require two values, delta square f of minus 1 and delta square f of 0. Once again, we have to draw two lines for two values. Those are, this is the first one and this is the second one. And once again, and we have to remember this sequence. First, we have to round two terms. After that, we have to round one term. From that term to, we have to round two terms. And from here to, we have to round only one term. And this is the particular value. And from here to, we have to round two more terms. So this is this one. And this is this. And from here to, we have to round one more term. So this is this. Now, if we check the values what we have rounded, is those values correct or not? We have to check it. So the first one is f of 0 and f of 1. Okay, these are two values, f of 0 and f of 1. Coming to the next one, delta f of 0. So it means we have to round the value in deltas. Okay. So the first value in delta is delta f of minus 2. Second one is delta f of minus 1. And the third one is delta f of 0. Yes, this is correct one. And coming to the next one, that is delta square f of minus 1. Yes, the second value in the second difference should be delta square f of minus 1. And the third value is delta square f of 0. Okay, so coming to the next one, that is delta cube f of minus 1. Yes, the second value in the third difference should be delta cube f of minus 1. Similarly, delta power 4 f of minus 1 and delta power 4 f of minus 2. Yes, the first value in the fourth difference should be delta power 4 f of minus 2 and the second value should be delta power 4 f of minus 1. Absolutely correct. Okay, we have to remember this particular sequence order in order to round the terms. Okay, so after rounding the terms, now we have to substitute those values in the formula. Okay, right, I am going to substitute the values in the formula. So this is equal to 1 by 2 into, so f of 0, we have to substitute the value of f of 0, that is 0.4965 plus 0.4974. Okay, plus, so the value of u is 0.3 minus 1 by 2 is nothing but 0.5 into, we have to write delta f of 0. So the delta f of 0 is 0.0009. Okay, so after that, once again we have to write u is 0.3, u minus 1 minus 0.7 by 2 factorial means 2 into delta square f of minus 1. So the delta square f of minus 1 is minus 0.0003 plus into minus means minus 0.0002 by 2. Okay, next, coming to the next difference, that is u plus 1. 0.3 plus 1 means 1.3, u is 0.3, u minus 1 is minus 0.7, u minus 2 is minus 1.7 by 4 factorial is nothing but 24 into, once again we have to write delta power 4 . So coming to the next term, that is u is nothing but 0.3 into u minus 1 means minus 0.7. Next 0.3 minus 0.5 by 3 factorial means we get 6 into delta cube. So the value of delta cube is 0.0001. Okay, so after that we have to write u plus 1. So 1.3 into u is 0.3, u minus 1 is minus 0.7, so u minus 2 is minus 1.7 by 4 factorial is nothing but 24 into, we have to write delta power 4, that is 0.0001 plus 0 by 2. Okay, so I have substituted all the values in the formula. So on simplification we get the value of f of 2.73 is equal to 0.49679. Okay, this is the value of f of 2.73 by using Bessel's formula. So I have given you 2 more problems for homework. In the first problem, we have to find f of 27.4 from the table. Okay, and in the second problem, you have to find 3.75 from the table. Okay, so you may choose x naught by anyone. Okay, in the first problem, 27.4 lies between 27 and 28. So you may choose either 27 or 28 as x naught. Okay, so similarly, in the second problem, 3.75 lies between 3.5 and 4. You may choose either 3.5 or 4 as x naught. Okay, thank you.